So we've mentioned already that NPV is our primary tool used to make capital investment decisions. So now let's take a look at this more in depth. And we're going to do so in two stages. The first stage is we're going to discuss how to calculate NPV. And then the second, we're going to discuss the NPV rule. How do we use it to make a final decision? Let's start with number one. How do you calculate NPV? Well, by definition, net present value is the difference between the market value of a project and its cost. So the cost is pretty simple. The cost is the price tag for the piece of machinery. The market value is the value that that piece of machinery is going to generate for us. Or in other words, it is the present value of all of the future cash flows that are going to be generated by this piece of machinery. Another way of thinking about this, comparing the market value with the cost, is how much value is created from undertaking this investment. And at the end of the day, we said that's exactly what we want to answer, is how much value are we creating for our shareholders? That's why NPV is our number one decision rule. And so now let's get into calculating NPV. There's three steps here. The first step is to estimate the expected future cash flows. So we already have that set up in our problem. We've estimated the future cash flows from purchasing this piece of machinery. The second step is to estimate the required return for projects for this type of risk. That was already given to us as well. That was the 12%. We said that 12% is going to adjust for two things. One, the fact that all these cash flows aren't occurring today. It's going to adjust for the time value of money. And the second, because these cash flows aren't occurring today, they entail risk. The further those cash flows are down the timeline, the more risky those cash flows. And so that 12% adjusts year over year for the riskiness of these projects. We can spend a lot of time, in fact, chapters to come, on how we actually came up with the 12%. For our purposes here, we're just going to use the 12% to reflect that risk. And then finally, the third step is to find the present value of the cash flows and subtract them from the initial investment. Now, technically, you may have a stream of positive cash flows and negative cash flows. In our first example, the only negative cash flow occurs up front. This is what we call a conventional project. You pay a price up front and it only produces positive cash flows in the future. We can have other non-conventional projects, and for those we would need to discount both the negatives and the positives back to today. We take the difference between them, hence the name net present value. We're netting the positive benefits from this investment from the cost of this investment, all on a present value basis, hence the name net present value. We'll take a deeper look at these steps later on using our example. Now let's move on to point number two, the NPV decision rule. How do we use our NPV to give us a yes/no decision? And so the answer is very simple. If NPV is positive, you accept the project. A positive NPV, we've already said, means that the project is expected to add value to the firm. It will therefore increase the wealth of its owners, increase the wealth of shareholders. In fact, the anticipated increase in shareholder wealth is precisely the amount of NPV. That's why we like NPV so much. It's giving us exactly what we're wanting to know. Are we increasing shareholder wealth? So if our goal is to increase owner wealth, NPV is a direct measure of how well this project is going to meet our goal.